When you hear someone use the term SVT to describe one singular rhythm, it is widely accepted that they're talking about this rhythm right over here. However, most practitioners are getting away from using SVT to describe one rhythm and one rhythm alone. The reason is, in reality, SVT is an umbrella term to describe 7 different rhythms that generate in the atria and above the ventricles. SVT by definition means supraventricular tachycardia. So, a tachycardia that is above the ventricles and has a rate of above 100. Now, the 7 rhythms that SVT covers are sinus tachycardia, AFib, A-flutter, multifocal atrial tachycardia, junctional tachycardia, atrial tachycardia, and finally AVNRT, or AV nodal reentrant tachycardia. And the interesting thing is that whenever you have this rhythm and somebody calls it SVT, well, as long as the patient is stable, what is the treatment? Vagal maneuvers and then adenosine, right? Well, adenosine only works on one of those 7 rhythms that we just named, and that's AVNRT. So if you have a patient who is in, let's say, a flutter at a 1-to-1 ratio or something like that, and you give them gallons and gallons and gallons of adenosine, it's not going to make a difference. Adenosine will only convert one and one rhythm only, and that's AVNRT. And AVNRT is actually, so let's talk about it. Before we start, let's do a quick review of the supraconductive pathway, or at least part of it. We know that up top we have the SA node, and at the junction we have the AV node, and then we have our 3 internodal pathways. This one is the superior anterior tract, but most importantly the fast tract. This one right here is the middle tract, or Wenckebach's tract. And this one right over here is the inferior posterior tract, or most importantly, the slow tract. Now, in about 90% of the population, the only internodal pathway that comes and truly attaches to the AV node is the fast tract. The middle tract and the slow tract, they actually terminate somewhere in the right atrium. Now, in about 10% of the population, the slow tract will also come down and attach to the AV node. And these are the patients that could have AV and RT. So what happens? Well, when we have our AV node, fast tract, and the slow tract, every time an impulse comes down the SA node, it comes down the fast tract and the slow tract at the same time. However, the fast tract is going to make it to the AV node much, much faster. It will travel down the His bundle and the left and right bundle branches, and also up the slow tract. However, then it meets with the impulse that's coming down the slow tract. And once they meet in the middle, they will cancel each other out. And this will happen 99.999999999% of the time. And there is no issues. And these people can live completely normal lives, and there is no problem. Now, every once in a while, we can have an incident where a circuit reentry happens. Now, for a circuit reentry phenomenon to happen, you have to have 3 different criteria met. One is that you have to have at least 2 different routes. Well, we have 1 and 2. 2, the second thing you have to have is that you have to have different properties. Well, we do here, right? One is a fast tract, one is a slow tract. The number three thing, the third criteria that needs to be met is that there has to be an area of slowing in your circuit. Well, this one by definition is called the slow tract. So we have all three criteria that need to be met for a circuit reentrant tachycardia, or excuse me, to a circuit reentrant to happen, between the fast reentrant to happen, between the fast tract, slow tract, SA node and the AV node. So what happens in these cases is that you will have like a PAC, right? Let's say a PAC occurs right over here, and it starts sending a wave of impulse throughout the atrium, right atrium. Well, at what point it might hit the slow tract first. So then this impulse will travel the slow tract, goes down to the ventricles, up the fast tract, comes down the slow tract, into the ventricles, up the fast tract, and this happens very, 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 very fast. And this will give us what we call an AV nodal reentrant tachycardia, NRT. Now, the interesting part about AV NRTs, or what people like to call SVTs, is that if you actually have a patient who is in PSVT, right? If you just happen to catch a person go from a normal sinus rhythm into SVT, or a patient who is in paroxysmal SVT, meaning it comes and goes, if you pay attention, every single PSVT starts with a PAC, which they have clearly marked right over here for us in this example. So you have a patient who is having a normal heartbeat, throws a PAC, and then bam, we have AVNRT. Let's see, I have another example. Here's another example right over here. If you were to look over here. Look at the P waves in all of these beats right over here. They all look the same. They all look the same until bam. Look at that P wave right there. Completely different morphology than all the other P waves. So then what happens is, because that is a PAC, it puts the patient in what we call AVNRT.